Alright, I'm going to go through this as fast as I can. I'm going to briefly explain how to get all the answers, and if you want to see the work, you can just pause it. For this first one, because it's a less than, you drop the bars and you put the argument between the number and its opposite, and then you just kind of work it out from there. I have all the answers boxed. For the second one, right, when you get rid of the 8 and the 2, what you wind up with is this situation here, and since it's a greater than, you have to break that up into two different inequalities, and then you just solve those away like that. And for this third one, it's the same thing, only you don't have to solve for it first. Because it's a greater than some number, you drop the absolute value bars and set the argument equal to the less than or greater than the number and less than its opposite, and then you solve those, and that's what you get. Okay, solve for x. This one just factors, or if you want you could complete the square, but this one happened to factor out pretty nice. Second one. Alright, what you want to do is, because it wasn't like plus something or 1 plus something here, since it was just one fraction equals one fraction, I just cross multiplied and worked it out from there. I got a quadratic. It didn't factor, so I hit it with the quadratic formula, and I went from there to here is the final answer. Okay. For this one, I wanted a common denominator. Well, no, I didn't. I either could have got a common denominator and then cross-multiplied like I did in the last problem, or I chose instead to clear the fractions by multiplying through by this times this. Right? So in the first one, the x's cancel, and you're left with x plus 1, x plus 1. In the second one, the x plus 1's cancel, and you're left with x times the 4 plus x, which gives you that. But you don't forget to do it to the other side also, so the 1 works like that. And after it's all on one line, you're just going to want to do the regular thing, take everything to one side, try to factor it. If it doesn't factor, go with the quadratic formula, and that's what you get for that. Alright, the inequalities, get everything on one side, make a sign chart for the two factors. And since we wanted less than 0, you take the ones in between with one where it's negative. So between 0 and 3, including. For the middle one here. Alright. Again, bring everything on the one side. It factors. But since it factors into a square, no matter what you plug in for x, you're always going to wind up with some number times itself, which will never be negative and will always be at least 0. So since the original problem wanted this one, the answer is all real numbers. Its sign chart looks like that. It's always positive. And the next one, you just find out where it's the value of x that makes it 0 and the value of x that makes it undefined, because those are the possibilities. Those are the zeros, the possibilities for them for the whole expression to change sign. And this one happens to have this sign chart, so since we wanted greater than or equal to 0, we take between 3 and 4, including 3, because I could plug 3 in, but excluding 4, because if I plug in x as 4, I get minus 1 over 0, which is not a number. So we exclude that. Alright. It says find all zeros of this function. So since it's just like this, just factor it as much as possible, and you factor it into this times this, and then this thing factors further into this times this. So you set the individual factors equal to 0, and you get 0, 5, and minus 4. Page 1. Page 2. Alright, we wanted, with the line there. Alright, first I would just do this, because this is the most useful form. Right? You want to have y isolated, since the first one wants a line that's parallel, so it's got the same slope. So the way that I had taught it was that you do y equals y1 plus m times x minus x1, where the x1s and the y1s are the coordinates of the points that you know. And if you set it up in that fashion, this is what you get. You get 12 minus 5x has to have the same slope. For a perpendicular line, it has to have the opposite reciprocal slope. And since I said the x-intercept is 4, that means we're using the point right there, 4, 0. So I use that point as my x1, y1, and use minus 1/5 as my slope. And you work it out, that's what you get. Once to describe the effects of these transformations, this first one will shrink everything in by a factor of 1/2. So if the function used to look like, say, something like this, the transformed version would be twice as close, I guess you could say, to the x-axis. So it's going to shrink it in by a factor of 2. The x minus 5, since x has to be 5 more than it used to have to be to give the same outputs, it's going to be 5 units that away. F of x minus 4, this first establishes f of x as the function, and then from those y values takes away 4 units. So that's going to shift everything down by 4 units. This one is going to do two things. The 2, if you get the function starts out like that, that's going to double the y coordinates. Alright, twice as far as they were. And then it's going to take that result and bump it up by 1. So the final answer would maybe be something like this. Alright, it stretches by a factor of 2 vertically and then adds 1. And for this one, since if this is the old graph, we'll say it's this. Since it's f of 2x, 2x is going into the old function, and x has to be half of what it used to be to give you the same outputs. So it's going to shrink in horizontally by a factor of 2. Alright, the old school cell phone plans, what you had was you got to set up this, kind of think this out in your head. The total cost is the monthly cost plus the cost for the minutes. And so you would say the 53.24, which is what you had. That would have to be the fixed cost, which you didn't know, plus the 15 cents for 175 minutes. And if you take that equation and solve it for x, you get $26.99. So that's the upfront cost. For the middle one here, the cost of a loaf of bread goes up from $1.80 to $2.29. So you're taking $1.80 and you have to multiply that by some number to increase it to $2.29. The number by which you multiply it, if you solve that thing for x, is 127. So that means that it was an increase of 27%. The new number is 127% of the old number. What's this? Alright, this is the same kind of thing, only you were given a decrease of 19.5%, right? It was going down, and it ended up at 69.4. So what you're supposed to set that up is like you're left up with since something decreased by 19.5%, you're wanting, like, it's turning into 80.5% of its former self. That's what I'm saying here. So if you look at it that way, the way to read that is 0.805 or 80.5% times some number gave you the 69.4. And when you solve that for x, you get 86.21. Alright, the cigars one, the way to set that up, first of all, I had to change that. I had to change the, what do you call it? I had to change the given amount to 17,378.1 so that the problem actually worked out. But the way that it goes is you would set up the Monarch plus the Churchill has to add up to 78. So the thing that you think in your head after this is you would add the profit from selling the Monarchs. So it would be this times the number of Monarchs that you sold, or this, plus the other amount times the number of Churchills that you sold. And you would get that equation. It must equal the 17378.1. So this is like your profit equation, alright? So it's these two. Now if you take this and you replace the m, you want to get it in terms of one variable so you can solve it. So replace m with 78 minus c. So you get 226 times. Now it makes sense that the two amounts, they should complement each other because that's the number of cigars cigar boxes that were sold. But this one times this number plus this amount times this number has to give you the total. And when you multiply this out and add the number over to the other side and then factor out a C and so on, you get C is actually equal to this expression, which when you divide gives you 18. And so since they had to add to 78, the monarchs were 60. Interval notation. Here we go, right? Everything less than 32, that's this. Okay, so it's less than this negative number or greater than this. The way to say that is this union with this. This is a between situation, so we don't need two separate sets for this. We can just write it up in one, right? X is between 15 and 250. Well, that's exactly what this means, so there was no work to do there. Now this says, this one is kind of different. It's X is less than 5 and X is greater than negative 3. So numbers like -4, -5, and -6 are not in this entire thing because it says and. The numbers that this thing has to represent must be things in both of these. So that's why an intersection is required, right? Everything up to, well, this means and. But what that means is all the numbers that are greater than -3 and at the same time less than 5. So the way to write that is really like this. I only need one for it. Alright, for the domains, for the domain ones, they kind of come in two types. Ones with fraction bars and others with radicals. Now, for the fraction ones, you're going to want to say pretty much all real numbers minus maybe 1 or 2 or 3 numbers that are not allowed to be plugged in. So in the case where it's a division one, we're going to be talking about what we rule out. And in the case of the radical ones, we're going to be talking about the numbers that we want. So you keep that in mind for these. For this, you're going to want it, because it's a division, you're going to want to rule out a couple numbers. So you want to rule out the numbers that cause division by 0. So you just take the denominator, set it equal to 0, and solve. And the numbers that you get will be the numbers that you want to rule out, as is the case with the fraction ones. Same thing here. It doesn't matter what's in the numerator. If it makes the denominator only 0, that's sufficient enough to keep it out of the domain. Because if I try to plug these numbers in either case, I'm going to get a nonsense answer. I'm going to get some number divided by 0. And as soon as I write that, I know that I've done something wrong. So you can plug anything in here except for these two numbers. This one is fine because there are no fractions, there are no negatives, so you can plug any number in for x, and the output is always going to be some number no matter what you plug in. Alright, here's a radical one. With the radical ones, typically we set it up so that so that out pops the actual domain. We want to make sure that 2x minus 3 is greater than or equal to 0. So that's the way that you set this inequality up, and the solution of the inequality will be the domain. So what's going to be ruled out of this, like in this case, is going to be done sort of implicitly, because when we want to make sure that 2x minus 3 is greater than or equal to 0. And when we solve that, that means that x has to be greater than or equal to 3/2. So this indirectly tells us what to rule out by telling us what to keep, any number greater than or equal to 3/2. In this case here, the argument factors nicely, and we want to know where is this expression greater than or equal to 0. So it's an application of our inequality solving skills. And when you want to solve the inequality just like this, and you would set up a number line and mark down the 3 and the -5, and then pick a test number in each thing. So this is what comes out of that. X is greater than or equal to 3, or x is less than or equal to -5. If x is in either of these two sets, then this is guaranteed to be a positive number, and so when you take its square root, it'll be real. And for this thing, what you would do is you would set this equal to 0 to find the numbers that you want to rule out. But when you solve for x, you get this well, no, you'll get x is radical minus 5, and that's not, and that's, yeah, no, the radical goes underneath, plus and minus square root of minus 5, and so that's not a number. You can plug in anything for x, nothing will cause division by 0. Let me zoom out here for a second. Alright, I'll read the questions and tell you what the answers are. It says evaluate f of 2. So f of 2 is 0, because it's right there. That's 0. And then it says solve the equation f of x equals 2. So it's asking you what numbers give an output of 2. Since 2 is right here, the two numbers that make f equal to 2 are 0, because f of 0 is 2, and negative 2, because f of negative 2 is 2. And it says solve the inequality. F of x is less than or equal to 0, so you want it's asking for the values of x that make f, or that make the outputs negative or 0. So f of x is negative when it's under the x-axis, so that's all these here. So the answer is actually x is between 2 and 3. The domain of f is the set of the inputs, so that's all of these numbers. So the way that you would write that is x is between minus 3 and 3, and the range of x is, the range of f is as for the set of the outputs. Only these numbers are, let me mark them in green, only these numbers are outputs. Right, so the answer to that would be x is between minus 1, y is between minus 1 and positive 3. It says to give the y-intercept, the y-intercept is 0, 2. Give the x-intercepts, the x-intercept is 2, 0. Compute f of 1, that means that you do f of 1, and then you do f on the result, so f of 1 is 1, and f of that, if you refer back to the chart again, is also 1, so f of 1 is 1. Finally, it says suppose that g of x equals x squared plus 1, and they want you to compute g of f of 0. So first you do f of 0 from the chart. F of 0 is 2, and then you do f of 0 is 2 from the graph, and then you do g of that, which says squared and add 1. So that's 2 squared plus 1 is 5. This one down here, combine and simplify. So you're dividing by a fraction, so you're going to want to invert this and multiply. So this pre-factors into this. The 6 comes out, and then this factors, whereupon what you're left with is this thing here. And so it's good news. Everything is factored, so we can, and everything is being multiplied. So we're free to cancel here. So cancel this with this. These x plus 1s will cancel. Right, this will go with this. This 2 will cancel with, this 2 will cancel with this 4 to give you 2. But then this surviving 2 will cancel with the 2 and this 6, so that you'll wind up with, ultimately on the bottom, just a 3. And finally, one of these x's cancels with one of these x's. So the only thing that you're left with after you do this is there was one x on top, and on the bottom there was a 3 and an x minus 1. And that's what it simplifies down to. Lastly, perform any cancellations. You first have to factor them, and then, because you can only cancel factors, so this factors into x and x minus 2. The bottom actually factors into x plus radical 2, x minus radical 2. So there's nothing that's going to cancel in this one because they don't have any factors in common, so you would write OK for the first one. The second one, they don't have any common factors. The only factor on top is this. The only factor on the bottom is 5. They're not common, so this is OK too. This third one, you can factor a 2 out of the 14 minus 2x, and the top, and then the 7 minus x and the x minus 7, those are opposites. So what you could look at it this way. You could further factor out a negative 1 from this, which would leave you with minus 2 times x minus 7 divided by x minus 7. And then the x minus 7s would cancel, and this simplifies down to just x is negative 2. This last one. Alright. You can factor out an x, and then this factors in x plus minus 2x minus radical 2, but clearly that doesn't appear on top, so we don't have to bother factoring it. But this will cancel with one of the x's on top because this is x times x, and so this results in x divided by x squared minus 2, and that's as good as it's going to get. And this, the top one here, factor out a -1 from everything, and then you realize that they all match, so the top matches the bottom, and you're left with -1. Perform the operations and simplify into one fraction. So with this one, because it's subtraction, you need a common denominator. Let me zoom back in. Yeah, you need a common denominator, so the common denominator is x plus 2 times 5. So multiply this one by 5 over 5, multiply this one by x over 2 over x over 2, and then you get something. Once you do that, you can the denominator will be common. You can just add them like that. So you get 15 times x, and this is squared because it's this times itself. And when you multiply all that out, this is what you get. I don't care if you put the negative out front or whatever, but that's how it's done. I'm just happy if you can add the fractions up. This one here is division, so you have to invert and multiply through. So when this times this over this times this gives you just this. Same thing here, division. 4 divided by this is 4. Some people like to write 4 over 1. I don't particularly, but that's how it, if you like, you can look at it that way. So you get this times this, and that just multiplies out to that. Again, a division, when you divide this by this, you just invert and multiply, and that's what you get. For the completing the square ones, let's see, I'll walk you through one. Well, alright, so let's see. Zoom in a bit more here, get in tight. Let's try to focus here. Alright, so you have to take out the 2. I like to do it for the first 2. You should probably practice doing this with all 3. Factor a 2 out of everything so that there's a 5/2 here. Just see how the problem works out when you do it that way. You should get the same answer if you did everything right. But the magic number that you need in between is half of 5 squared, so that's 25/4. Add it and subtract it. The first 3, therefore, break down into that, and then you just carry this down as usual. So then this condenses into that. Then you put the 2 back to both of these, and multiplies like that, and then you add the 5 in the fraction, and that's what you get. And so to locate the vertex, it's going to be the opposite of the 5/2 and the -35/2. So since it says locate the vertex, complete the square, figured out, that's what you get. For the second one, take out a 1/3. Again, you should try doing it with all 3. Make sure that you get the same answer to check your algebra. The first 3 terms. Oh, alright. Half of 3 is 1/6. Squared is 1 over 36. So you add it and subtract it. So that breaks down to that, and then this just gets carried down like so. Put the 3 back in to just the first 2. Combine the fractions on the end, and that's what you get. So the vertex is at 1/6 comma minus 49/12. And the last one, since it's all over 2, I see this like this. So this to me is less scary looking than how it's written here. So that's how I choose to interpret it. So basically, I'm just going to complete the square with what's here, and then just in the end, remember to multiply the result by the 1/2. So I do that. Magic number is 4 plus and minus. Only in this case, it's nice because the 4 and the -1 combine nicely in the -5. While the first 3 automatically factor into that. And so these combine for this, and then finally put the 1/2 back in. So the vertex is at 2 minus 5/2. Lastly, we got to identify these functions. So this one is a transform of an absolute value. It's shifted 2 to the right and 2 down. So it would be like that. Right, x minus 2. This does the right movement, and this does the down. The second one is a line whose y-intercept is -2 and whose slope, I got these 2 points here, since I go over 3 and up 4, the slope is 4/3. So I just put that in straight up, mx plus b, right? It's 4/3 x minus 2. And then with this one, it's a radical x function, right? The radical x looks like this, kinda. So we see it's been flipped down, and then the result was moved 2 units that way, 2 units to the left. And to do that, you say, you take 2 and add it to the x, and then you flip that around, and that's what you get. If you have any other questions, you can feel free to just send me an email, or find me maybe upstairs in the library sometime before Wednesday. I'll be happy to help you.